It's for Spencer. Okay.
Shalom, Spencer.
That's a good one. Okay, so
What do you have to say, Mr. Ryan?
I said that's a good one. Shalom, Spencer. Okay, 3.6, 3.9 practice test. This is your last test of the semester. This is an opportunity to raise your grade. Woo.
Wait, did you miss? That's a scan triangle?
We're going over this.
What's an opportunity?
The test. We're practicing for the test. This is the last test of the semester. It's a great opportunity to raise your grade.
You're forgetting about the other house.
What? What's your question?
What are we doing after we finish the test? We're sitting in silence.
Oh my God, were you not here 2 minutes ago and I went over what we're doing?
No, that was.
I literally, right. So that's probably a problem. This is probably how you miss the fact that Mr. Labita said it twice. I moved the test. This is how you miss it because you don't pay attention, you don't listen.
No, he actually didn't.
Okay, he did. All right. So after the test, we're reviewing for the semester final. Chapter 1, Chapter 2, first half Chapter 3, second half Chapter 3. That's 4 days of review. Okay. Let's do number 1. Y equals square root of cosine to the 4 theta. So, what are we trying to do? Find the derivative of each function. Simplify completely. You must completely simplify. If you don't completely simplify, you'll get points off. So, I write way too much on your quizzes and tests. It takes me too long, but my hope is you read through and you don't make those same mistakes again. Do not make the same mistakes from your quiz on the test. That would be great. Don't do it. So, y prime. First, let me rewrite this just so I can see it a little clearer. So I have cosine of 4 theta, and this is all to the 1/2 power because it's square root. One thing to notice, if I have cos by itself, this is wrong. Don't write this. I'm not doing cosine times 4 theta. This is not product rule because cosine always has to be cosine of something, right? Here it's cosine of 4 theta. The reason we use chain rule is because we're taking cosine of a function, right? We have a function inside our cosine function. So we're going to use chain, exactly. So first, you bring the 1/2 down, and then you have to rewrite everything. What is 1/2 minus 1? Negative 1/2. It's because negative 1/2 minus 1 is negative 3/2. You're close.
Wait a minute.
We're not done yet. Okay, so that's the outer portion. We need to do the inner. So times by negative sine of 4 theta. And then there's actually, you can't even see the green. Can you see this one better? Maybe. Times 4. That's not different. Whatever. So that is chain rule. The rest of simplification is algebra. So let me do the numbers first. 1/2 times negative 1 times 4. So I'm just taking 1/2 times negative 1 times 4.
4 theta is 4.
Derivative of 4 theta is 4.
Is the derivative of 4 pi 4?
No, because pi is a number.
Oh.
Theta is an angle. So pi is 3.14 blah blah blah. But theta, what angle are we dealing with? Theta is, I could replace theta with x. Yeah, it's my variable. So I have negative 2 times sine of 4 theta. Good question, are we good? Okay. This negative right here. So I have 1/2 times negative, blah, blah. Exactly. So that's why I waited to write it, because I can get rid of the negative and the exponent by writing it down here.
Divided by cosine.
Square root of cosine 4 theta. This is the answer.
Can we go over like a little mini lesson about like the negative 1/2 and the power and the square root and all that?
So,
The negative
sure.
and positive.
Square root, the exponent, if I have square root of x, that's x to the 1/2. If I have, let's see, square root of x to the 3rd, this is x to the 3/2. What was it, Maya or Noah or someone like?
House. That's me. That's what
Yeah, top dog in the house.
You're gonna thank me later.
Top dog in the house. So whatever is on top is actually inside the house, inside the radical.
I really know. All right.
Yeah. That's why I was like, I knew one of you guys had that. Okay. What? It's on top. It's inside the house of the root.
Oh, I already knew that.
But if there's like a
Right.
negative
It's just.
in there,
I'm about to say it. Ready? Focus. 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 I'm about to explain negative roots. Just a little review. So if I have 1 over root x, this is the same thing as x to the negative 1/2 power. Because negative turns it on the bottom of the fraction, and then 1/2 is a root, the square root. Yep. Okay, what other questions do you have, Hannah? Do you have a specific question? Specific question about that? So, question, if I have like 1 over cube root of x to the 5th, how would I write this?
Maybe
X
to the
negative sits on the bottom,
5 over 3.
top is inside, right? And cube root. Perfect. I don't know. Okay, focus. Try on number 2 if you have not already. We're going to go over it. We are going to, but I want you to try it first. Then we'll go over it. That's why I said then we'll go over it. Okay. Yep. So d dx of e to the u is equal to e to the u times du dx.
So it's just the same thing in terms of derivative.
Yep. Literally, it's going to be the same thing. And then whatever the derivative of your exponent. Derivative of your exponent. That's what du dx is saying. Whatever the derivative of whatever is in here. So, what about this -8? Normally when we take derivatives, we just multiply the constant out front, right? So, I'll multiply by -8. Okay, and now I have e to the x over 2. And here my u is x over 2. So it is chain rule in the sense that the definition of e to a exponent that is a function is just going to be e to the function times whatever derivative that function is. So e times -8 times e to the x over 2 times the derivative of x over 2, which is 1/2. So this is just going to be -4 e to the x over 2. Yes, Elliot.
How come you have to do the derivative of -8?
Because -8 is a constant, just multiplying.
Where are you getting the one?
So hold on. So if I had if I had -8 x to the 3rd power, what do we do with the -8? Right, we just multiply and then multiply by the 3, right? So it's no different. We're just multiplying by up front.
You just keep the x.
What? I'm sorry, what?
I think I'm confused because there's an x.
So the x and
Did you
the
bring the x over 2 down?
no, because it's the derivative of u with respect to x. The derivative.
X is 1.
So du is right. 1/2 x is just 1/2. Versus if this was like x squared in the exponent. If I had e to the x squared, the derivative would be e to the x squared times 2x, because that's the derivative of the exponent. So that's a little different example. Okay, so this is our answer. E's always follow this rule right here.
Okay. Oh, that's like that. No.
Yeah, that's exactly the chop. You try to take the derivative.
Like I'm crazy.
You know what I'm talking about? No?
Again? Wait, so this is like x over 4, the derivative is just 1/4.
What? Hold on.
It's the one where you multiply.
This is what she's talking about. Yeah. Okay, sorry. Abby, what's your question?
If it's x over 4, the derivative would be 1/4.
Yeah. Because that's literally 1/4 x. X over 4 is just 1/4 x.
Oh, are we gonna have one that's like formatted differently?
No, so we deal with e's. Number 4 and 5 I think would help as well. Because we deal with e again. Okay. ln of 5x. Ooh.
Can you scroll up for
Yeah.
Okay.
Yeah?
And then just really quick while we're here.
Yep.
Why don't you do the product?
Shh. This is not a product. Because a product of two functions. -8 is not a function.
Oh.
Good question, because other people probably the same one. Okay.
Is this product?
No. Chain. Chain.
Chain.
because we have, it's not. We have the inner, right? This part is the middle. And then we have this like outside one. You see how it's like we have a function inside the ln function, inside an ln function. It's a composition. Okay, so first we're going to do the outermost one. So f prime of x. So derivative of ln of x. 1 over ln of 5x times the derivative of what's inside. Okay, so this was for the blue part because literally the derivative ln of x derivative is 1 over x. So if let me write out the rule. So derivative of ln of u is just 1 over u times du dx. So what all this means,
1 over ln of u, but here you're writing 1 over
because here my u is ln of 5x. This is my u, and then what's the derivative of ln of x? 1 over 5x times, well, I'm literally using the same rule. Okay, 1 over 5x times the derivative of 5x times 5. Derivative of 5x is 5. Okay, derivative of, let me write it out. Maybe that would help. So, let's say f of x equals ln of u, where u is equal to ln of 5x. So, I say 1 over u, which was, right, 1 over ln of 5x, times the derivative of ln of 5. Okay, well, shoot. Now I have ln of 5. Derivative of ln 5 is 1 over u. Well, here, now my u is equal to 5x. I'm writing a different color. Can you tell the different color? Okay. So now this is my f of x, and now my u is 5x. So I do 1 over u, which is 5x, times the derivative of u. Okay, what's the derivative of u? 5. So I'm using the chain rule. I had to use the fact that the derivative of ln is 1 over x, but I had to use that twice in a row. Okay, now if we simplify it out, I see 5x go away. They cancel out. So I'm left with 1 over x ln of 5x. I'm going to write that nicer. 1 over x ln 5x. Do you have a question about this one in particular? If so, raise your hand. I'll make sure to answer your questions. Yeah.
Can I just say, if it was 3 times 1 over ln 5x, and it was times 1 over 3x,
then it would just be 5. Right, so if this was like a 3 here instead, and this was a 5, use a different color so it's clear. Okay, so if this was a 3 and this was a 5, I would have 5 over 3x ln of 5x. I wouldn't be able to cancel out the 5s.
can you make it ln of 5x squared or no?
Where?
Instead of x ln 5x, can you make it ln 5x squared?
No. Because technically, this, using the power rule, I could write it as 1 over ln of 5x to the x power, right? Because if you want to bring it in, that would be the power, but why write it that way? That's dumb. Not dumb, sorry. Not beneficial. It's not beneficial to what we're trying to do. Okay, so this is the derivative. Let me make that very apparent. Y prime, okay. Okay, so I'll leave it up there. If you haven't already, try number 4. Give about 5 seconds. Try it out. That's all it should take you, is 5 seconds. This problem,
number 2.
very similar, very similar. So number 4 is your what's good with Hanukkah? Like, what's the thing?
Presents, I guess.
It's your present for Hanukkah. There you go. It's your present for Hanukkah, number 4.
I don't get presents. I guess.
Latkes, is that the potatoes?
That's so good.
No, it's not true.
Okay. Okay, so we've tried it out. We tried it out. Here we go. So y prime.
I just took out a guess. I believe I'm right.
Negative 2e to the negative.
E times negative 2x. And what's the derivative of negative 2x? Negative 2. So y prime is just going to be negative 2e to negative 2x.
Yay.
But do you put negative 2 over
E to the 2x?
Negative. Oh, I mean, you could.
Oh. Okay.
That. Because I did take points off if you left a positive exponent. If you left a negative exponent.
For real? So you'd have to do. Wait, how did that?
You're welcome, guys. Wait, why not? Wait, why? You guys would have gotten it wrong on the test.
Because it's simplify completely means no negative exponents.
How come you brought the negative to there? Wouldn't it be what?
Negative 2 right here. It's still up here.
Oh, because you're multiplying 1 over.
Because this is.
Okay.
That's not why people did that. Not at all. 1/4 a point for not simplifying completely is not right. Out of like 4 points for a problem. What? You think I would take it off all?
You said you took off a point.
1/4 a point. What's, okay, think about how many syllables sing. A point. 1/4 of a point. I'm trying to like be efficient today.
Like you can get 4/4 of a point off in this one.
Right.
1 point. Whereas if you got 1 point, it'd be 4 points.
If you did like the negative exponent for 2 problems right next to each other versus doing it for like 3 or 4 times, it's also different. If you did it everywhere, take off a point. If you only did it like in one place, 1/4. Did in 2 places, I forget if I was like nice and only took off 1/4. Because it was the same problem. I mean, come on, Abby, you know me. I give like partial credit. Don't turn on me. You know me, okay?
Okay, so if you have a negative exponent, you can just bring it on down and
Yep.
put the bottom of that, right?
Yep. Yep. Because like x to the negative 2 is the same thing as 1 over x to the 2. You take the negative away from your exponent and put it on the bottom. Okay. Uh-oh, what do we have here?
Product.
I think it's product.
And a little cha-chain.
No, honey.
Yes, the V1 is cha-chain.
Stop today.
Tell me I'm wrong.
Stop today.
No, because sign has to have an X connected to it, so it's not necessary.
But is
Right.
it cha-chain?
U is chain.
Stop saying that.
U is chain. The U. The e to the negative x.
Say it was right. No way.
U is e to the negative x. So U prime, it is going to be x to the negative x. And then we have to multiply with negative 1. Ah.
U prime is
Okay.
So that was chain. Okay.
Right. But how come there's no cha-chain? She just said there was chain. No,
There was
for
for,
V1.
because
No chain. But why?
this is not, because it's sine inverse of x.
But don't you take the parentheses?
Well, sine, you can't just have sine to the negative 1 by itself.
Yeah.
You can't.
No.
Because it always has to be, has to
Then
always
you
be.
just multiply by 1.
is it not?
Right, so that
It's not
technically,
going to change it, but are you technically doing what you're changing?
yeah. Technically,
Not going crazy.
no, you're not. Okay.
I thought sign equals
So
to
Brian, how do you find
Sign negative 1.
U prime. So you do e to the x, so just the normal e and then the derivative of the exponent. So you take e to the negative x times derivative of negative x is just negative 1. That's why I just put negative in front. Because technically it's e to the u times du dx. So that's just going to be e to the negative x and the derivative of negative x is just negative 1. So that's why I have the negative right here. Because technically I was doing this rule with e. Okay, so v prime. This is one of the 2 things I'm having you know. AP Calc AB has to memorize all 6. You have 2. Right. Sine inverse, cosine inverse, tan inverse, cosine, a cotangent inverse, secant inverse, cosecant inverse. All of the inverse, right. You only know 2. So, we know what this is. 1 over square root of 1 minus x squared.
Wait, Mr. Brian, I'm confused. What? Like, what I would personally put is 1 over cosine.
It's an issue.
You get that?
No, I do. I get where you're coming from. Because if this is just sine of x, the derivative is cosine.
And then I just put it in.
And the issue is it's not to negative 1 power. This negative 1's denoting it's an inverse. So this is why like this is why here first one I immediately rewrote it with the exponent and notice it was like cosine of this whole thing. Okay. Notice, hold on. Okay. If I had sine squared of x and I want the derivative, immediately I would rewrite this as sine of x squared.
Yeah.
Okay. But the issue is, if we have sine inverse of x, I can write this as sine of x, like the negative one? No, that's not the same thing. I can't just write it that way. That's not the same thing. Because this is denoting it's an inverse function, not to negative 1 power.
So why is it?
This is the inverse function, so it's a sine inverse.
You get one of them.
That's what you have to memorize.
This is one of the two things you have to memorize.
And what's, if it was
From
cosine-
3.9, trig inverse functions.
If it was cosine to negative 1x, it would be...
I made you do tan inverse, not
you didn't know
cosine.
tan and sine. And sine
Tan and
is-
sine.
You write tan.
Number 6, the next one. Yeah. Okay, so I have a product rule right here.
Wait, I have a question.
Hold on, I'm gonna wait till people are quiet. Okay. When? So when you're multiplying two functions. When you're multiplying two functions, use product. Notice I'm multiplying two functions. Versus number 3. Like, wait, number 4, this is not two functions. Number 3, okay, well, I see multiple functions, but they're inside each other, so it's a composition. I'm not actually multiplying two functions. I have a composition of functions. I have ln of x inside an ln of x. Okay. So, I have product rule, and we know product rule is going to be u v prime plus v u prime. So u e to the negative x times 1 over, and I'm just going to, okay, I'll write it, 1 over square root 1 minus x squared plus v, okay, sine inverse of x. Inverse is different than to the negative 1 power. Inverse, special, make a star for yourself. Times u prime, which is negative e to the negative 2x. Okay, so we just gotta simplify this a little bit. What? No, there's not supposed to be a 2x. I'm sorry. What? Right here? Because it's plus.
Oh, okay, I thought it was minus.
So, quotient rule. Quotient rule is take, right? Quotient rule has a negative that is subtract in the middle. What? Did you just miss what I said? So, she's asking. Pause. I'm literally talking right now. So, she asked where this positive came from. Came from the fact it's a product rule.
I thought it was minus.
But I was saying, wait, no, you subtract when you have quotient rule. So that's what I was saying.
Okay. I thought there was going to be quotient rule within the one.
Yeah, no. I could ask you quotient rule. Okay, we're not done. We gotta simplify this. So what is in both of these terms? Is there something I can pull out?
E to the negative.
Yeah, e to the negative x. So I'm left with is 1 over, let's see, 1 minus x squared plus, when I pull out this part, this turns into a negative 1. So multiplying by negative 1 turns this into minus sine inverse of x.
Wait, this is minus.
Yeah.
No, I think we should keep going because there's so much.
We are keep going. I just see people writing, scrambling. We are gonna keep going.
It's Monday.
Maybe I should have just had your test today. Like, why? Why? If you guys are gonna study and like ask real questions, if you're gonna be goofing off, then not impressed. Not impressed right now. Oh my gosh.
But then when you take out the e to the negative x,
Yeah.
don't you?
So
Because you
so ideally when you have a negative exponent, I'm talking about when you have like a fraction and it's a negative, move it down. if you have e to the negative x, like I'm not going to be as picky if you're going to bring it to the bottom of a fraction. So if you're left with like x to the negative 3/2, that you can easily put on the bottom. So I'm talking about places I took points off of your quiz. If you have x to the negative 3/2, expectation is like you know how to write this as 1 over x to the 3 over 2.
Well, that's not the answer.
No, it's not the answer. Okay. I don't, like, I'm trying to talk about, like, when do I care about if you have a negative in your exponent or not?
So for E and
So here, we pulled out an e to the negative x. I'm not going to take off points if you left it because it's already a complicated problem. Versus the last one on the front page of your quiz, I took points off if you left a negative in your exponent because this is something that you should have been able to put on the bottom easily. So this time, all I'm going to do is rewrite the answer so it looks a little nicer. So I have e to the negative x to the 1 over square root 1 minus x squared minus sine inverse of x. That's where I'll leave it. That's where I'll leave it. Are you okay? I don't know if this is like happy tears or not.
oh no, this is like a
That's sad tears?
yeah.
Okay. Okay.
Oh.
It's nice of you. Okay, so number 6. Number 6. I don't take it personal. Let's do number 6. Okay. Number 6.
I'm looking at number 6 now.
So y equals tan inverse of 3 theta.
Chain.
Exactly. Chain rule. It's chain rule. Because 3x is inside tan inverse. So first you have to do, so remember it's literally, what? Okay. If you need a moment, you can step outside. Okay. I'm screencasting, so it is what it is. Y prime equals, okay, derivative of tangent is 1.
Is this the second thing I have to memorize?
Yes. Yes. If I take the derivative of tan inverse of x, it's 1 over 1 plus x squared. So, if I take derivative of tan of u, aka I have a function inside, it's 1 plus u squared times du dx. So, I have 1 over 1 plus 3 theta squared plus, multiplied by the derivative. What's the derivative of 3 theta? 3. Because you're treating theta as if it's a variable. So, to simplify this, I will say this is equal to 3 over 1 plus 9 theta squared.
I don't know why. Wait, 9 theta squared.
3 squared is 9, theta squared is theta squared. Because it's 3 theta squared.
It's not like
that's not too bad.
deal.
As long as I remember that, which I'm not gonna.
There's the spirit, I guess.
So the difference between the tan inverse and the sine inverse is that sine is in the square root and tan does not have this.
And a minus.
Oh yeah. So for the
Hold on. Gabe.
Why is it 1 plus 9 theta? Do we square this?
3 theta squared is 9 theta.
Then why does the squares stay?
Because theta squared is theta squared.
oh because you're squaring it out.
Yes.
It's like x.
Distribute the square. Okay, questions on the first page. Okay. So keep in mind, you get 1 extension per year. Not semester, year. Okay, cool. And your finals are the 2nd through 4th of April, or whatever. So you have 3 full months of learning.
Has a college ever asked for someone to send his semester grades?
Yeah. In order to finish your enrollment, you have to send.
You don't. You don't need to send them.
The only carry fail.
Well, because if like they need your transcript. College counseling sends your final transcript. Yes. Which is why if you don't get your community service done, they hold your transcript and they don't send it to your college. This happens every year, as Ms. Bonstein said. Community service.
And then
If you don't do community service, you don't graduate. Okay. Okay. Shh. Use logarithmic. Come on. Focus. Use logarithmic differentiation. Define dy dx. Logarithmic differentiation. First step, ln, both sides. Let's take ln, both sides. See, you know what you're doing. Okay, ln of y equals ln of x to the sine of x. Then you have to use rules of exponents with logarithms. Yep. Use rule of logarithms for exponents. So ln of y equals sine x times ln x. Next step. Oh my gosh. What do you notice? What's happening on the right side?
It's product.
Product rule. This is u. This is v. So I'm going to literally list it out for myself. U is sine of x. So that means u prime, the derivative is just cosine x. V is ln of x. V prime is just 1 over x. Perfect. The issue, okay, so we know product rule is going to be u sine of x times v prime, 1 over x, plus v ln of x times u prime, cosine of x. So that's my right side. The left side's, I don't know, trickier, because logarithmic differentiation uses implicit, because we're taking the derivative with respect to x. But wait, I have y on the left side, right? I have a function of y. So what I'm going to say is derivative of ln is 1 over y times, y itself is a function of x. So I have to say times y prime. Or you could say dy dx, doesn't matter. Huh? Do you want me to say, okay, you know what, I'm going to say dy dx. Because that's what we're looking for. It's the same thing as y prime, right? We're trying to find dy dx. Notice I have dy dx on the left side. What do I have to do to get it by itself? Multiply everything by y. So dy dx is going to equal sine of x over x plus, I'm going to say cosine of x, ln of x. It doesn't matter the order. It's fine. You know what? I think people will be angry. I'll keep it in the same order. ln of x times cosine of x. Now, don't forget, I got to multiply by y because I'm multiplying both sides by y. But wait, what is y equal to? X to the sine of x. So remember, logarithmic differentiation. Take ln of both sides. Bring the exponent down. Use product rule. And we'd use implicit differentiation. Move the y on the right side. Then replace the y with what we originally had, which was up here. We're going to replace it. So dy dx is just going to be sine of x over x. I'm just rewriting what I had before. But this time, instead of just saying y, I'm going to say x to the sine of x. Question. When do we use logarithmic differentiation? When do we use it? When do we use it? Besides when I say use logarithmic differentiation, when do you actually use it? Yes.
When the exponent is like 2 functions.
When you have an x in the exponent and base. Yeah.
Oh, sine of x over x.
Yeah.
Then why would
Well,
you do that?
when you have it as the base and the exponent. So if I have x to the x power, sine of x to the x squared or something. When you have a function of x to a power of a function of x. Question? I don't know. No? So let me just box this guy.
That's the answer?
Yeah, that's it.
Wow, that's annoying. So long answer.
Yep.
Do you have to put it in brackets?
Nope, you can use parentheses.
Oh, can you not use parentheses?
Said you can use parentheses.
She just said
Shh, it's fine, you can use parentheses.
What if you just use a dot in between there?
In between what?
Just put
Like right here instead?
yeah.
Right here? Then you're not multiplying it to the left side. You have to multiply it by both. Both terms. I think I've written this a couple times. Parentheses are our best friend because it has correct grouping symbols. Grouping symbols. Okay. I think sometimes I use brackets just so like I can be super clear if I have to have like multiple brackets, multiple things. Okay, use implicit differentiation to find the following function for 8 and 9. Am I good to scroll up? Yeah. Okay, find dy dx. Okay, so keep in mind this 2 over x. Do you want me to scroll up a little bit? So 2 over x is the same thing as 2x to the negative 1. Cool. Okay, find dy dx. So I'm going to use implicit differentiation. So I'm going to take d dx of this whole thing. Y squared, and then take d dx of 1 minus 2x to the negative 1. What? When we get to that point, yeah. So, okay, what's the derivative of y squared? 2y, and then you can write y prime. Is that what you're asking? Yeah, in my solutions I write dy dx. Equals derivative of 1, 0. Derivative of 1, derivative of a constant is 0. Minus derivative of 2 to the x minus 1. Derivative of 2 to the x minus 1. So you take negative 1, bring it in front, so negative 2x to the negative 2. So that's just going to be, let's see, negative 2, oh, let me write it this way. Negative 2x to negative 2. Yes. So I have 2y times y prime equals 2x to the negative 2. I need to get y prime by itself. Keep in mind, y prime is the same thing as saying dy dx. All it means is first derivative. Divide by 2y.
So there's no chain rule on this?
No. Well, there was right here, technically.
But not on the x side.
No. So I have 2 x to the negative 2 over 2y. The 2's go away. And I'm left with 1 over x squared times y. Why did I put x squared on bottom? Because it's x to the negative 2 power. So I have y prime is equal to 1 over x squared y. Question? Yes?
Whenever you're taking the derivative of y, you always have to multiply by the prime, right?
Well, when I'm using implicit in the sense that, like, it's not just y equals something, it's y squared. So it's a function of, it's not just like y by itself, because it's y squared here. So when you say implicit differentiation, every time you run into a y, you have to multiply by y prime. Take the derivative using the rules we've done so far, and then multiply by y prime. Tack on a y prime. So if you had a different teacher, they might be like, tack on a dy dx. It's the same thing. Yes?
Why don't we put back in y?
We don't need to, because we don't have y by itself. I got the y by itself. I got y prime by itself.
Oh. But on the last problem, we could get y by itself and then we still try to
I mean, it doesn't, but in this problem, we had y equals, like, y alone, versus here, it's y squared. We don't have an equation for y. We have an equation for y squared. No, because it's plus or minus root. That's the whole thing with implicits. We're trying to avoid the plus or minus, because that's 2 distinct functions. We only want 1. All right, find the slope of the tangent line at the point 0, 0. Okay, so the way you find it, dy dx, I'm trying to find what is the value at 0, 0. So I'm plugging into my equation. So it's equal to 1 over 0 squared times 0. Wait, what? 1 over 0?
Oh my god, that's like not a number.
So it's undefined. Did I answer your question?
Yeah.
Okay.
Oh my god.
Well, I wasn't going to say it like that, but that was my point. Okay. So we have 2 more minutes. So the issue is, all we've done so far was mostly review. I mean, we reviewed some of the last 2 sections. We mostly only reviewed the beginning. I would like to review the rest of it. Yeah.
Can we take the test on Thursday and then just do the next week?
So,
Black out we can do
right. So,
already so far.
that's what I was, no. But have you take the test tomorrow? It's not going to be good. So the test will be Thursday. Oh, what is this? Thursday. Wait, do I have all eyes on me? No. I want every single eye on me. I'm saying it to your face right now. When is test? Thursday. Am I gonna like remind you? No. No, I'm not. Oh my God. So, what I am expecting tomorrow, you need to go through your chapter 3 first part test. Read all the comments I made for you. Go through the quiz you got back last week. Go through the comments. Don't make the same mistakes, okay? Please, don't make the same mistakes.
I won't let you down.
We're gonna, wait. We're going to finish the second half of this tomorrow. I need you to make sure you're here and ready. And